centers, which we are referring to as the other centers of triangles. Remember, we had discussed about 3. One of them was, so we are going to look at other centers of triangles, and we had discussed 3. So if you can remember the first one, kindly raise up your hand. Just one. You can remember. When you are doing the circles, yes, Charlene? In center. Okay. So who can remember circumcenter? Okay. So that was our second. And finally, the third one, Wanja? Excenter. Yeah, so those are the ones that we had discussed previously. So today, we are just going to look at other centers of the circle, which are basically 2. So there are 2 new things that we are going to discuss, or 2 other centers of the circle. One of them is called centroid. This is new. One of them is called centroid. And another one is called the orthocenter. Orthocenter. So these are the new ones that we are introducing today, other centers of the triangle. Of course, we know as we were going through other centers of the triangle, number 1, number 2, and number 3, we were drawing circles. But on the last 4, the last 2, the centroid and the orthocenter, we are not going to draw any circle, but we are just going to construct them. How do you construct a centroid? How do you construct an orthocenter? So we are going to start with the centroid. So we will define what the centroid is. Then of course we look at how do we construct it. So for today's writing, kindly indicate your subtopic as other centers of the triangle. And of course, we'll not number it as 4 and 5, but you'll number them as 1 and 2. So on that note, when you're writing your notes, please, centroid will be number 1, and the orthocenter will be number 2. Then of course, we will start with number 1. How do we draw a centroid? And what is a centroid, or how does it come about? So we'll give us time, of course, to write other centers of triangle. Then you do number 4 and of course number 5. But we've said number them as 1 and 2. Okay. Our number 1, I want to believe we have indicated our number 1 will be centroid. Yeah. And that is what we will focus on. Centroid. Something about centroid, and you write a centroid is a point of intersection. A centroid is a point of intersection. Is a point of intersection of the lines joining. A point of intersection of the lines joining. The midpoints of the lines joining. The midpoints of the sides of a triangle, midpoints of the sides of a triangle, to the vertices of the triangle, to the vertices of the triangle. So, to the vertices of the triangle. So let me explain what I've just, this meaning of that statement diagrammatically before we go to the drawing. Sawa sawa? Yes. So if we have a triangle, so what are we trying to say? We are saying that for you to get a centroid, then we have the medians of the sides. What do we mean that by the mid? It's just the middle point. Like we have side A, B. That is side A, B. This one here. So if we want the midpoint of it, that is what we are referring to, the median. Then at the middle there, of course, we are going to construct it. I'll take us through. So we are saying if I get the midpoint of AB, again, I get the midpoint of BC, and I get the midpoint of what? Of AC. Then I join from this midpoint to C. We'll see how to construct it. Again, I join from this midpoint to A. That's what you say, from midpoint to what? To the vertices. We know what a vertex is, where two lines join at a point. So if this is the midpoint of VC, then what we are saying, if I join this one to A, again I take the midpoint of AC and join it to what? To B. Then, sorry, that one did not come out well, but they should meet at a particular point because of course we have not constructed. So let me just use a ruler so that it would come out well. Okay. So I will change this as a midpoint so that it's, so when, this is what we are saying, at this point where they are meeting is what we call what? Centroid. Are we together?
Yes.
So what are we going to do? We want to see how do you construct a centroid. Is that okay?
Yes.
So of course we must do the construction of the median. So I may use this board and this board depending on how the pair of compass will behave this other side. So if it doesn't work, we'll use the blackboard. But all the same, I know we now have a rough idea of what a centroid is. So maybe in our books we are going to write how to draw a centroid. How to draw a centroid. How to draw a centroid. Number one, draw the required triangle. Draw the required triangle. Number two, construct the median of the sides. Construct the median of the sides. Number three, join. Number three, join the median to the vertices. Join the median to the vertices. Join the median to the vertices. So we can look at an example with measurements that we are going to do. I'm hoping all of us, we have the instrument that we require. So we can look at example one, and I'll give us a question that we are going to use. Just write example one, then we do the construction. Example one, draw triangle ABC in which, draw triangle ABC in which AB equals to 6 centimeters on the board. Then we have BC equals to 5 centimeters. And of course, angle ABC equals to 40 degrees. From it, draw the centroid. From it, draw the centroid. So I'll wrap this, and now what do we do? Each person has the measurement, yeah? So you have your ruler, we know how to go about drawing. So we know the measurements of the triangle. So what are we going to do first? Draw a straight line. Okay. So you will draw your straight line. So we'll use this for now. Draw a straight line. And of course, after drawing a straight line, we have been given the measurements of the triangle. So everyone, draw your straight line. After that, we can choose which point to be at the base. So what are we going to do? We've been told that AB is what? 6 centimeters. So what do? Using your pair of compass, you measure how many centimeters from the ruler? 6. So use your ruler, measure 6 centimeters. So mine, I'll extend a little bit so that it becomes bigger for all of us to see. So we measure 6. Then what do? You come to the line you've drawn, make an arc, then come to this other line and make an arc. After you've made an arc, what do? You label it A and B. This should be 6 centimeters. Okay, so we've done that. The other 5 centimeters. So what do we do again? Use your pair of compass and take the measurement from where? From the ruler. How many? 5 centimeters. Come here, stand at B and make an arc. Stand at B and then make an arc. We have been told angle B is how many degrees? 40. All of us know. Can we construct 40 without using a protractor? Not really. So in that case, what do? Use your protractor and at B, measure 40 degrees. In case you've forgotten how to measure 40 degrees, this is how you put your protractor. There, you push into the arc that you had made. And remember, we want the angle inside. This is our 40 degrees. Then just mark that 40 degrees there. So you can mark it using a point. So once you have your 40 degrees, what do? You use your ruler and put it here at the vertex. Let it go through that point that you've marked, and also it will go through the what? The arc. So we had created an arc there. That is it. Let it go through the point and through the arc. Where the first arc and the line that we have drawn meet, it gives us point C. Remember, procedure 1 is 2. So what do? You join C to what? To A. That is it. And now we have our complete triangle. We've not drawn the centroid. Is when we are going to draw the centroid. So, kila mtu hapo. So all of us have our triangles. Okay. Now what do we want to do? We want to draw the median. How do we draw the median from this? I'll start with AB. Just getting the middle of AB. So what do? With your pair of compass, you stand at A with the sharp end. Then slightly just take more than what? More than half. Then what are we going to do? This is an easier way. So it's sliding here, but we are going to make an arc. You can make it up there and again down. Are you seeing that? I don't want to go. This is a shorter way of doing it. So you can make an arc like that. Then from here again, what do? Make an arc. Unaona zitakutana hapo juu and again itakutana wapi? Chini. So once you do that, what do? You use your ruler. But let me just repeat in case some of us did not get. We want to draw the median of AB. How can we draw the median of AB? At A, you can take more than half. Make an arc up and again down. Of course, it can be very long, but for me it's not necessary because we are interested in where they are what? They are crossing or they are meeting one another. So like this, an arc up like that, you can extend it down, no problem. Then down, then come and stand here without interfering with your pair of compass. Make an arc up and just what I've done. So you'll have them crisscrossing there. Then what do? Use a ruler and join like that. So when you join this, you'll realize that this line at this point, it has divided line AB into 2. So at this point, it's the middle of AB. Remember, we are creating what? Median. Aya kila mtu achore the first median. What we mean by doing the median. Then after that, who has not done the median? C. We are going to do for A, C. So how do we do for AC? Again, stand at where? A. just slightly more than half. Then make an arc. Are you seeing mine? Then bring it. We are saying you can extend, no problem. Then come again and stand at C. Then the arc segments. So we want to draw the centroid. What do we mean? This is our median. Are you seeing that? At this point? This is a median. Please look at it. Though it has crossed this one, there's a median here and there's a median here. So that if you measure C to this point and this point to A, they will be the same. A to this point to B, they will be the same. But we haven't drawn our centroid. So how do we draw the centroid? From this median, we draw it towards the vertex opposite the line. So line CB is opposite vertex A. Line AB is opposite vertex C. So we join from this median to C, like that. Then we join from this median to what? To B. I don't know if this you will see it well. Okay. The lines I'm creating. So we've joined those ones. Then I'm yet to join this vertex from A to this median, this one of mine here. So I hope you're seeing it. But of course, as we are doing it, it will come out. Okay. So where the medians meet, I hope you are seeing it here. This is what we call the what? The centroid. That is what we call the centroid. So can we try it out? Can we try it out? Join median to vertex. Median to vertex. I think using a straight line, the way I've done mine, can you label your centroid? Label your centroid outside the diagram. Using a straight line. Label centroid outside the diagram. So since I've guided us in drawing that, anyone with a question on that? Drawing a centroid. Somebody? First step. How do we go about drawing a centroid? Yes, Pet? First step. You draw the required triangle. That is the first step. Step number 2, somebody else? Yes, Philip?
Construct the median, the sides.
Yes, that is key. You construct the medians of the sides. And finally, the last one, Whitney?
Join the median to the vertices.
Yes, you join the median to the vertices. But which median to which vertex? Which median to which vertex? Is it any median to any vertex? No? Yes, Anna?
The opposite to
Which, what opposite to where?
the line.
Si
The
uongee kwa
median.
sauti.
The median, you join it to the opposite vertex.
Yes. The median, you join it to the opposite vertex. So where they meet gives you the centroid. Any question? So can I introduce the auto center? Then of course now we'll do the exercise together. Sawa sawa? Yes. So the final center of a triangle, which is our number 2, is the auto center. Last one, which is very simple, that is called the auto center of a triangle. Okay, so I'll grab this one. Then we do another one, which is not really complicated in terms of we have drawn part of what is required before. So we are saying we are going to do the orthocenter of a triangle. But before we do it, of course, it's important that we do what? We define it. Okay, orthocenter. So define it very fast, please. Orthocenter of a triangle. We are defining it like this. This is the point of intersection. This is the point of intersection of altitudes. This is the point of intersection of altitudes in a triangle. Of altitudes in a triangle. Point of intersection of altitudes in a triangle. Okay. Before we even look at how we go about it, when we talk of altitude, what comes into your mind? When we talk of altitude, what comes into your mind? Another person? Inua mkono hivi. Yes, Ashley, what comes into your mind? Height. Did you get that? Yeah. When we talk of altitude, then height comes through your mind. Is that okay? So we are saying in this case, we are dealing with a triangle. All of us know, can we get height in a triangle? Yes. How? Just from one vertex to what? To the base. For example, allow me to, we have drawn part of what is required before. So we are saying we are going to do the orthocenter of a triangle. But before we do it, of course, it's important that we do what? We define it. Okay, orthocenter. So define it very fast, please. Orthocenter of a triangle. We are defining it like this. This is the point of intersection. This is the point of intersection of altitudes. This is the point of intersection of altitudes in a triangle. Of altitudes in a triangle. Point of intersection of altitudes in a triangle. Okay. Before we even look at how we go about it, when we talk of altitude, what comes into your mind? When we talk of altitude, what comes into your mind? Another person? Inua mkono hivi. Yes, Ashley, what comes into your mind? Height. Did you get that? Yeah. When we talk of altitude, then height comes through your mind. Is that okay? So we are saying in this case, we are dealing with a triangle. All of us know, can we get height in a triangle? Yes. How? Just from one vertex to what? To the base. For example, allow me to see. So if I drop this line down here, maybe I just use continuous line. This will be what? Height. So what are we saying? This one will be an altitude. But we are saying for you to draw the orthocenter, then we are going to create altitudes from all the vertices. For example, it is possible to create an altitude from B to which side? AC. It is possible to create an altitude from A to what? To BC. For example, if I draw this line to that, can that be the height of the triangle? Yes. If I draw from B to that point, can it be the height of the triangle? Yes. But look at that. Are they meeting at a point? Yes. So this is what we call the what? The orthocenter. But remember, we must do what? We must construct. So getting the altitudes from the vertices to the sides, and of course then we do what? We draw. So of course we want to see how do you draw the altitudes. In Form 1, you learned on how to draw a perpendicular from a point. How many can remember from Form 1? Yeah, some of you can remember. So that is what we are going to do. It's really nothing new. How do you drop a perpendicular? So we are going to drop a perpendicular from C to AB, drop a perpendicular from B to AC, and drop a perpendicular from A to CB. So I'll just take us through the procedure by using an example. So just write example. Draw triangle PQR. Draw triangle PQR with PQ 8 centimeters. With PQ 8 centimeters. Then QR 7 centimeters. QR 7 centimeters. And RP 6 centimeter. RP 6 centimeters. I have said PQ 8 centimeters. I've said the other one is 7 RP, and the last one for QR, and the last one is what? 6. The question is locate the ortho center. Locate the ortho center. So we are going to do it practically. So that's why I've not taken us to a long procedure, because we are done this in Form 1, dropping a perpendicular. So let's do that example, then we'll just have an idea. So what is the first thing again? We said for you to draw a triangle, what do? Draw a straight line. So we'll have our straight line. Then what do? Measure. In this case, I'll choose my base to be PQ. So what do? Measure 8 centimeters. So you measure using your pair of compass from the ruler. You measure your 8 centimeters. Then after measuring your 8 centimeters, you come to your line. Then do what? Make an arc, and also make an arc. So I've said I'll take this as my PQ. How many centimeters? 8 centimeters. After that, what do I want? I want QR, which I've told us QR equals to how many centimeters? 7 centimeters. Measure your 7 centimeters from the ruler. Then come. I'm looking for what? QR. Where do I start? At Q. Then I make an arc. So at Q, make an arc. Then I want the final one, which I've told us R equals to what? 6 centimeters. Go to my ruler and measure my what? My 6 centimeters. So we have drawn our triangle. For it to be complete, make sure that you join the points. Of course, this will be R. Join this point, and then we have what? R. Okay. Label your triangle. Then now what do we want to do? We want to draw the altitudes, or rather the heights. So what are we going to do in this case? I've said for you to draw the height, then you must drop a perpendicular from a point. When you want to draw height in a triangle, this is not like an isosceles that you can say, I'll just drop it down at the middle. Not really. We must draw what? An altitude or a perpendicular from a point. So how do we draw perpendicular from a point? I would choose my first point to be R. So if R is my first point from which I want to draw the altitude, what do? Using your pair of compass, you stand at what? Stand at R. Then at R, again, which line is opposite R? B, Q. Then we make 2 arcs on B, Q. So this is your pair of compass, you'll be there. Then we want to make 2 arcs on BQ. I don't know if you are seeing mine, like that. So I have 2 arcs. Let me just reinforce them. I've created those 2 arcs. So each person make 2 arcs on PQ. But from where? From R, like that. So there will be 2 arcs. Using your pair of compass, stand on the first arc like this, make another, so stand here and make another arc down. Then again stand on this other arc, the same, without interfering with the radius of your pair of compass when making the next one. So stand there and then make another arc down there. So remember, we are standing at the point of intersection of PQ and the arc to make the arc down. Point of intersection PQ and this arc, and make the other arc down. Once you do that, what do? You use your ruler and join from R through to this. So let me use a longer ruler so that we don't. Yeah. So you will be joining like that, and that is it. So join from R to the arcs that you created down there. You will notice that this angle will be what? How many degrees? 90 degrees. We've just done one altitude. What do you do again? You stand at P and create another altitude. So again, how do we go about it? Stand at P, open your pair of compass until you can reach the line. Then we want to make some 2 arcs on the line. So just trying to adjust it a little bit. Okay. So we have that arc and that arc. I've created those 2 arcs, one there and one here, on the same arcs. Another arc outside and another arc. They will meet. So they are meeting at that point. Then what do? Using your ruler from P to here, then you do what? You join. Using your ruler from P, of course you do what? You join through where the arcs are crossed and through to point what? To point P. So I hope we are moving on well. So we've only created 2 altitudes. We are coming to do is a little bit direct, because at Form 1 we are taught on how to draw perpendicular from a point. Are we together there? Yeah. So unless somebody has a question, I would say that drawing orthocenter and drawing centroid is even more cheaper as we compare drawing centers of a triangle. So as we wind up, how many centers of triangle have we discussed in this topic? There are 5, but I would wish that we remind ourselves just as we finish up. So I will start with number 1 again, if you can remember the centers. Lucy, in center. Number 2, Rabia, your hand was up. Circum center. Number 3, Yes, Mwana Hamisi?
X center.
X center. Those are the ones we did earlier. So today we have done 2. Number 1 was, yes? Centroid was number 1 for today. And finally, the one that we just finished with, Jackie. Ortho center. Yes, Mulki.
I have a question.
Yes,
When you
please.
are dropping the perpendicular from the point Q to the line PR, and when you're drawing that arc to PR and the arc is crossing R, can you extend the line?
No. Generally, we want the arc to be between the points P and R in this case. So just try that you don't really go too much outside. It can be at point R, no problem, or even point P. Is that okay? Yeah, so don't, remember it is ortho center of a triangle. Once you extend it, are you within the triangle? You are outside. So let's restrict ourselves to that. Just adjust your pair of compass accordingly.